Cool. So, we've gone through most of the mechanics involved in the essential mechanics for PA5. So the TR command for translating characters and so on and so forth. And I've given you a few sort of kind of randomly selected ways to use sed to do things like replace all consecutive spaces with a single underscore and things like that. But I want to spend some time talking about how sed works in general, so that we can do more particular editing of lines, and so this is something called regular expressions, and these are sometimes just called regex, because who's got time to say regular expressions? And the grep command, grep, this is actually regular expressions. So grep is actually, it's not just a way to search for something inside another string. It's actually searching for these things called regular expressions. And regular expressions are like wildcards on steroids. It's a way to search for not just a particular sequence of characters, but a sequence of characters that have certain characteristics. For example, we could say look for, one of these characters followed by two or more spaces followed by a digit, right? And we can concoct a search pattern for that, a regular expression, and feed that to grep. Or we could feed it to sed if we wanted to find such a pattern and replace it with something. Or we can use these same expressions inside VI when we say colon substitute / old / new. This is exactly the same thing that you would put into a sed command. And so sed is actually the stream editor. So ed is sort of the precursor to VI. That was the plain old editor. VI was the visual editor. Sed is the stream editor. So it lets you do things that you would do in this plain old editor, but lets you do them in kind of a batch mode. Set up a bunch of commands that you want to have executed on a file, and then run through those commands. And so all of this hinges around the idea of a regular expression. So I'm going to mess with this from the command line. Let's see. Yeah, we'll just play around on here. So for example, if I say substitute hello / hi, this reads from standard in and it writes the standard out, but each line that it reads, it applies this replacement to. It looks for the string hello and replaces it with hi. So if I say, hello there, it changes it to hi there. If I say, well, hello there, it changes it to, well, hi there. If I say, hello there, hello, hello, it changes it to, hi there, hello, hello. So the first thing to know about these substitution patterns is they work once on a line. This says, find an occurrence of HELLO and replace it with HI. And it could be in the beginning of the input, it could be in the middle of the input, it could be at the end of the input. But written like this, the first occurrence of hello gets replaced with hi, and that's all that happens. But this G switch that I've been telling you to use says repeat this substitution everywhere on the line. And so if I do this, hello there, hello, hello, it says hi there, hi, hi. So we have substitute old new, which just says replace once, or we can say substitute old new, and the G I was taught stands for global, so do it everywhere that it occurs on the line. So that's what we've been doing with the sed strings we've been concocting for PA5. All right, I think we got a quorum here. So go ahead and send me an attendance note. And we'll keep going with regex. All right, so substitute old, new. That's sort of the most forward, most basic approach, and we can put the /g at the end. We can also do wildcards, and so there's a few wildcards to know about in these regular expressions. A period matches any character. And pretty much across the board, when I use the word character, I don't mean a letter. I mean any symbol, any single ASCII character. So it could be a letter, could be a digit, could be a punctuation, could be a space. And so a period will match any of those. So for example, if I say sed substitute period // it's going to start at the beginning of my input string, and it's going to look for any character. And whatever character it finds, it's going to replace it with nothing. So if I say this is a test, it'll get rid of that first T. And if I said, you know, substitute a period with an X, then that first thing that matches a period, which is the first character on the line, gets replaced with an X. Now if I put a /g at the end of this, this is saying, hey, if you find a character in the line, replace it with an X. That's going to replace the T with an X. And the G is going to say, and keep going. See if there's another thing in the string that matches this pattern. Well, this pattern matches any character, so the H is going to match, and that's going to get replaced with an X. And then the G is going to say, keep going. See if there's another character that matches this pattern. Well, the third character, I, that matches a period, because a period matches anything. And so this is going to replace my entire input string with a bunch of X's. All right, so that's an example of a wildcard, and that's just a single period. Okay, another character to know is an asterisk. Oh, good question. So if you wanted to actually look for a period, we can do what's called an escape, which is a \. And so if I said something like, said substitute \, period with an X, right, that'll just replace the actual periods. And so \/ is a general escape in Unix and in C, and it basically says, you know, take the next thing literally. So take the period as an actual period. All right, so asterisk is another special character in regular expressions, and this means 0 or more of whatever character I put before the asterisk. So if I say, you know, search for something followed by an asterisk, it means I want you to match 0 or more occurrences of this something. So I could do something like this. Let's search for X asterisk, and let's get rid of it. But this didn't do anything because this letter T matches this pattern of 0 or more X's, and so that got replaced with nothing, and it only did that once. So let me put this G at the end. right? And so if I do that, it gets rid of all occurrences of x, and replaces each one with nothing, right? So it deletes them. Now I could have just done this by replacing x with nothing, but this is actually picking up patterns of x's, and so what we could do that might be more interesting is replace 0 or more occurrences of x with the letter x. In other words, take multiple x's and reduce it. And this is what we're doing with spaces in PA5, but it's easier to see what we're doing with letters than spaces. Now if I do this, right, something weird happens. And the weird thing that's happening here is that 0 or more occurrences of x, well, that matches everything, right? And what I really want to do is take, the following patterns. I want to take an x. I want to take 2 x's. I want to take 5 x's. I want to take all of those and replace it with just a single x. And if I just search for x asterisk, well, that matches every spot in my string, because every spot, even if there's not an x there, I can take any spot in my string and consider that to be 0 occurrences of the letter x.
Is this what the space star was?
Yeah, that's what the space star is. So the way I'm going to recognize these is I'm going to say x, x star. And this is going to say, look for an x followed by 0 or more consecutive x's. So let's look for an x followed by consecutive x's and replace that. And so now we've got what we were hoping for. All of these repetitions of x's got replaced with just a single x. And so if we do this with spaces instead of x's, right, that's how we take a line that has, 5 spaces between words and changes it into a single space. Or, just to close the loop on what we did before, take a space followed by 0 or more additional spaces, replace it with an underscore. Right, and so there's how we're building our phrases.
About something.
Yeah.
How could this be used in a real world situation?
What is real world?
I mean, for a job or anything like that? Because this is parsing or placing or replacing. How could this be used?
It's an interesting...
Person,
No, go ahead.
Say a person entered a space after they entered their credit card number.
Mm-hmm.
And then that credit card number would be entered with a space, but you know that they didn't mean to put that space, so you just get rid of all the extra garbage that's in there and parse it as a regular number.
Mm-hmm. Yeah, that's a good example. So like when you're on a web page and it asks you for your phone number, there you go, someone just said this, phone number is right. It used to be you had to type, parentheses, area code, close paren, space, exchange, dash, 4 digits, right? And now you can just kind of like type whatever and it fills it in for you automatically. And if you just type in 10 digits, it formats it. And that could, be done on the back end of a web page by using these kinds of regular expressions. So that's a good example also. But honestly, I use these kinds of regular expressions almost on a daily basis because I tend to live computer-wise in Unix, and when I pull down grades for an assignment, right, the grades come down from Canvas and it's last name comma first name, and to match it up with user accounts on the Linux machine, I really need first initial followed by last name. And I can do some of the things that we're going to do here to take a list of names with last name, comma, space, first name, and change it into first initial followed by last name. And I just seem to spend a good part of my life doing this, manipulating data. And you don't actually think about it like, no, I'm going to write a regular expression, but it's almost like breathing. And I'm probably a little more in a sort of data-centric position being a teacher, especially online, than others might. But yeah, so it actually does find application both in terms of programming, but also just in terms of day-to-day managing of data on a computer. And it's one of these things that will possibly feel fairly unnatural to begin with. When I first worked with this, it was like, kind of had to put everything aside and pull out my notes and try some things and so on. But eventually it started to feel like second nature to me. And it's like using VI. You just think DD when you want to delete something. All right, so asterisk is repeating the previous character 0 or more times, and often we'll do a character followed by a character asterisk, which says one or more occurrences of the character. And if I just do a single, character followed by an asterisk, like X asterisk, technically that pattern matches everything inside my input. So if my input string is, hexagon, and I look for an X star, this says 0 or more occurrences of the letter X. Well, right here in the beginning of the string, I have 0 occurrences of the letter X, so my pattern matches that. And right here, between the H and the E, I have 0 occurrences of the letter X, so this pattern matches that also. And this pattern will match basically everything in my input string. And so it's kind of being over-aggressive. All right, and this is something that we're going to want to keep in mind also. Regular expressions are greedy. They will try to gobble up as much as possible, and we'll see this with more complex expressions in a few minutes. If there's ambiguity as to what parts of a string match a regular expression, the answer is always going to be the thing that consumes the most characters. That's what the regex will actually match. So it goes for the most rather than the fewest. All right, so we've got periods for wildcards, we've got asterisks, we've got backslash as an escape. We can also use brackets. And so if I say substitute bracket A, E, I, O, U, this will match any of these characters. And let's just replace this with an uppercase V for vowel. And we'll do that globally. And so every vowel got replaced with the letter V. Now you could also do this by doing 5 different replacements. You could say replace the letter A with V, replace the letter E, replace the letter I, and so on. But sometimes it's convenient, you just have 2 things that you want to match. You can put them inside brackets. But I could also, just do multiple replacements and get the same result in the end. And sometimes it's useful to negate a condition. So if I wanted to match everything except a vowel, I can put a caret in the beginning of my pattern in the brackets. So I could do this. Let's replace everything that's not an A, E, I, O, or U. And let's replace that with a C for consonant. And so if I do that, everything except the vowels gets replaced.
spaces were consonants?
They're not vowels, so they're consonants now. Don't tell your English 101 teacher, though. All right, so the next thing is anchors. And what's an anchor do on a boat? It, like, you know, holds it in position. You drop your anchor and your boat stays there. So in a regular expression, we have two anchors. There's a caret and a dollar sign. A caret marks the beginning of a line, and a dollar sign represents the end of the line. And if you have an input string like hello, the caret is basically the stuff right before that H, and the dollar sign is the stuff right after the O. The caret is not the letter H. It's that sort of space like before the H, and the dollar sign is not the O. It's the thing right after the O. And so now we can start to do things like, for example, let's remove the last character from a line. So I can substitute anything followed by the end of the line with nothing. And if I say this is a test, it takes off that last character. Now if I just said substitute dollar sign with nothing, it's not going to change my input because the dollar sign does not match the last character. It matches the thing after the last character. So if I say look for two characters followed by the end of the string, it basically chops off those last two characters because the L and the O are followed by dollar sign, the anchor at the end of the input. So this matches the LO, and in this case I just replaced them with nothing. If I want to remove the first character, right, I could do something like caret period, and caret's the beginning of the line, period matches the letter A, and so if I replace that with nothing, that gets rid of my first letter. So some people were talking in Discord about underscores that were popping up in the beginning of their phrases after they split them up. So if we want to get rid of leading underscores, we could do this. Substitute the beginning of the line followed by an underscore followed by any number of consecutive underscores. Replace that with nothing. So if my input is just, you know, hello, it just looks normal. But if I start with an underscore, it will get rid of that. If I start with a bunch of underscores, it'll get rid of those. If I have underscores after that, those will remain intact because of this anchor. If I didn't put the anchor, then all of these underscores would get whacked off. But with the anchor in the beginning, we're only getting rid of the ones right here in the beginning. And then this does not match the pattern because, yeah, I've got an underscore, but it's not at the beginning of the line, and the caret says this has to be at the beginning of the line. So that might be useful in PA5, depending on how your phrasing comes out. All right, questions up to here, because we're about to make this really kind of bizarre. All right, so we're going to talk about registers. And this is where the real power of regular expressions kicks in. What we've done so far is great for searching for things. And, you know, if we're in VI, we can say slash to search for something, and we can search for something using a regular expression. So if we want to find a line that begins with a number sign, we could say slash caret number sign in VI, and that would say search for a line that begins with a number sign. So we can search for things, and we can do sort of rudimentary substitutions like this. Mostly to either get rid of things or to replace one thing with another. But the real fun with regular expressions starts to be when we can move things around in an input string. And so, for example, suppose we want to swap the first two characters of each line. Suppose we want to take a line like A, B, C, D, E and change it into B, A, C, D, E. So we want to move those first two characters into each other's position. And we can do this with a single sed command. So if I were to say substitute beginning of line, two characters, right? This first character, this first dot, is going to match the letter A. This second dot is going to match the letter B. And what I'd like to replace it with is the character that I matched here, the B, followed by the character that I matched here, which was the A. Alright, so to do this, I need to do the following. If I put parentheses around this pattern, then whatever character matches this is put into what we call a register. And it goes into register 1. And if I put parentheses around this, then whatever matches this dot, which in this case would be a B, that would go into register 2. And now if I want to use the contents of register 2, I can say \2. And if I want the contents of register 1, I can say \1. Alright, so this is going to say, look for the beginning of the line, followed by any character, put that character in register 1, followed by any other character, put that in register 2, and then replace those two characters with register 2, followed by register 1. So this would match the A and the B, and it would replace those with the B, followed by the A.
Wait, I thought the caret was the not.
The caret inside brackets is the not. But the caret is an anchor at the
okay.
beginning of a line.
Okay, thank you.
Yeah, it's multiple levels of multiplicity. All right, so let's try this. Oh, and one more thing, just to make it even more fun. So parentheses, when we use them in this way, we have to escape them. So we're going to have to put a \/ in front of the parentheses. Otherwise, it will just look for a parentheses followed by a period followed by a parentheses. So we've got to escape those. So now we've got, this ASCII character soup. Substitute beginning of the line, parentheses, dot, parentheses, dot. And let's replace it with register 2 followed by register 1. And if I say sed, all right, A, B, C, D, E, right, it swaps the first two letters. If I only have two letters, it swaps those. If I only have one letter, it won't match this second pattern, right? And so this substitution will fail, and it'll leave the line unchanged. And if I don't have anything on the line, it doesn't substitute anything, right? And so we're taking our string, we're breaking it apart by matching a pattern. We're taking the pieces that match those patterns, putting them into registers, and then using those registers over here. So if I wanted to repeat the first letter of each line 3 times, I could do this. Match at the beginning of the line a single character, take the character that matches, put it into register 1, and now replace that with 3 instances of register 1. And if I say hello, it repeats that first character a total of 3 times. And so now it becomes kind of a puzzle game to figure out how we can do different changes to an input string by using this mechanism of matching and putting into registers and recalling registers. And so, for example, suppose I have some sort of input string that looks like this, and I want to swap the first and the last characters with each other. So the first thing to do is match those characters. So I want to start at the beginning of the string. I want to match a single character. And then I want to match 0 or more additional characters. And then I want to match one more character followed by the end of the string. And this will match the entire string, but this period will match that first character. This period will match the last character, and this pattern will match all the stuff in the middle. So let's put these in parentheses. And let's replace with register 3, which was the last character, followed by register 2, which was the middle stuff, followed by register 1, which was the beginning stuff. And I won't put the backslashes in front of the parentheses here, because then it becomes totally unreadable. But we'll use the backslashes when we actually write this in SED. And so if I say hello, it swaps the O and the H. And so you can start doing a lot of different kinds of manipulation and processing on text strings using just these things that we've talked about for regular expressions. Basically matching particular patterns, using a dot for wildcards, using an asterisk for repetitions of a pattern, possibly putting things in brackets to choose from a number of things that you want to match, using anchors, and using parentheses to put things into registers. And so you can find websites that will let you exercise your regex skills, where you can type in an expression and type in a regex, and as you type in the regular expression, it'll show you what's matching what and what's going into the registers and so on and so forth. And that can be a fun way to play around with these. But let me give you some more examples. So if I know my username is Nick Macias, what I'd like to do is turn that into a user ID NMACIAS. And so how could I do that? Well, I could search for the beginning of the line, followed by one character, followed by anything that's not a space, followed by a space, and let's put all of this in a register, and then let's match a single character, which would be the beginning of the M, and let's replace that with the first initial of the first name and the first initial of the last name.
And would you do a TR to make it all lowercase?
And then I put a TR to make it all lowercase, exactly. I don't feel like this is gonna work, but yeah. Regular expressions are very easy to write and almost impossible to read. And so if I mess it up, usually I just write it again from scratch, because who can read this and understand what it means unless you're a computer? But
I was about to say that is like the hardest code I think I've ever seen.
yeah, this is why I don't ask a lot of regex expressions on exams, because I end up cross-eyed staring at these things. So, but
just include them as extra credit, you know?
I know, right? But I do have some ODPs that I might spin out with this. So yeah, so this is an example of doing this, and the way that we wrote this, we said let's look for a set of things that don't have spaces followed by a space. So what happens if I have multiple spaces on my input line? Right? Well, it did my first initial, it dropped everything up to and including the space, and then it went ahead and took what came after the space and basically used that as my last name. So if your name might contain, multiple things with spaces, what do? So we could do the following. So I could say substitute, beginning of the line, let's find the first thing. That's going to be the first initial. And then let's just look for anything followed by a space. And then let's look for a period. And let's replace that. So this is where the greediness comes in, right? If I say look for any collection of characters followed by a space, and I have an input like this, well, here's a collection of characters followed by a space, so this should certainly match dot star space. But this is also a collection of characters followed by a space. Character, 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 and a space. So the greediness is it's going to use all of this to match this pattern. It will try to match as much of your input line as possible. And so if I use that as a pattern, right, then it becomes the first initial of the first part followed by the last name in this case. So if I do that, then it gets me back to N. Macias.
If it tries to like replicate what you do or whatever, but it can't, will it throw an error?
No, so if, for example, there's no spaces at all in here, it just doesn't match the pattern, and so nothing gets replaced with anything, and your input just gets past your output. So it's nice that way. All right, so that's obviously not something that you're an expert in now. If this is the first time you've seen it, it's probably pretty confusing, right? Trying to figure out what this is and so on and so forth. So maybe we'll play around with some of these tomorrow. I might pull up some practice problems and we can work on them as a class tomorrow. Let me think about that. If we don't do that, then I want to go ahead and I want to talk about SED more generally, and I want to talk about awk as tools that we can use to write programs to do these kinds of things in addition to other sorts of processing. But that's an intro to regular expressions, and like I said in the beginning, you can do this in SED. You can also do this in VI. If I was in VI and I said colon and then typed all of this in, it would do that same operation on the current line of my file. If I said colon 1 comma dollar and typed all of this, it would do this operation on every line of my file. So it's a pretty powerful mechanism. All right, but we are out of time. So go ahead and send me an attendance note on the way out, and have a great afternoon, and I will see you tomorrow.
Thank you.
Bye-bye.
I got a quick question.
Yeah.
Have a wonderful day.
Thanks. You too.
So how do I take the output of a string and store it into a variable? Because in PA5, instead of printing out